Hello, everyone, and welcome to Data Platform Summit 2020. My name is Anand Raman, and I lead the program management for Azure Cognitive Services at Microsoft. It's been a great pleasure to be a part of Data Platform Summit for the last 5 years. Here are some great memories from last year where I had an opportunity to keynote at this event. I want to thank Amit Bansal and the rest of his Data Platform Summit team for pulling together an event this year under unprecedented times. We have over 200 sessions with 30 of my colleagues from Microsoft presenting. I would call this one of the largest events in the world and certainly the biggest in Southeast Asia. I hope you all take advantage of this and then being a part of this. We have many talks from Azure AI services, and I want to kick of this event with a talk on running Azure Cognitive Services at scale. Before we begin, I want to thank all our knowledge partners, including Microsoft. And we have some interesting ideas and prices and participation information from Amit and the team. Agenda for today's talk, it'll be an hour followed by a Q&A. Please feel free to ask questions as I'll be part of the talk, answering your questions as the talk is progressing. In the first part, I will cover running Azure Cognitive Services at scale and how we are able to scale our services running 23.5 billion transactions per month. After my talk, I have two exciting demos by my colleagues. Chris Hodder from my team will speak on computer vision services, and we'll show a demo on how you can get started with computer vision services. Followed by Gary and Chris, they will talk about how to enable speech in Azure bot services. Hope you enjoy the rest of the talk and looking forward to connecting with you in the question and answer.
Good morning, everyone. My name is Anand, and I'm super excited and honored to be here. Today, we are living in unprecedented times in many dimensions, and it's great to see this group come together to discuss and share technological breakthroughs while we are all collectively going through some difficult times. Today, I'll be sharing with you how we operate Azure Cognitive Services at scale for production services and applications at Microsoft. To help set the context, I'll start with an overview of Azure Cognitive Services. After the overview, I'll go a bit deeper into the services and then talk about the challenges and lessons learned with scaling these services. Azure Cognitive Services provides developers with a wide range of out-of-box pre-trained intelligent capabilities from computer vision, speech, language services that extract meaning from unstructured text, decision services with reinforcement learning. These services are pre-trained models with our data, and we do not store any customer data. These models are also customizable with your data. With Azure Cognitive Services, our mission is to bring the most comprehensive state-of-the-art AI product from Microsoft to developers. These capabilities are available to developers as REST APIs, through our client libraries, and through integrations with other products. Cognitive services can also be deployed anywhere from cloud to on-premises or any other cloud using containers. We are seeing tremendous momentum from Samsung to BBC to BMW to Starbucks to build applications that can see, hear, understand, and accelerate decision making. We've been seeing similar acceleration internally within Microsoft, with cognitive services providing translations, captioning, and dictations in our Office products. One of the biggest reasons for customer momentum is our ability to operate and deploy these services at scale. Our AI begins with breakthrough research. We have been doing this fundamental research in AI since the start of Microsoft Research 27 years ago. In the last 4 years, these breakthroughs we have had achieving human parity milestone, from object recognition to speech recognition to machine reading and comprehension, have all accelerated. Just in fact, in July this year, our teams achieved human parity in image captioning with natural language image descriptions. Let me provide some details on the recent image captioning human parity milestone. NoCaps, or the Novel Object Captioning at Scale Challenge by Facebook, evaluates AI models on their abilities to generate image captions describing new objects that are not present in their training data. In July this year, we at Microsoft pioneered the visual vocabulary pre-training technique that led to the industry's first of surpassing human performance on the NoCaps benchmark. As you can see, we are also at the top of the NoCaps leaderboard. Here is an example of image captioning before and after this milestone. More importantly, in less than 2 months, we are able to bring this capability into our production across 27 Azure global regions and serve at scale with a simple cloud API call. Our ability to bring the research milestone to production is enabling applications like Seeing AI, empower build blind users to understand the world around them better with this capability. Today, I want to share with you how we are bringing these breakthroughs into our products at scale to empower every developer and organization. Now, let's dive a little bit deeper into these services. The vision models offer services that help business to extract data from images and video. We offer a core set of base features and capabilities in our computer vision service. These are out-of-the-box, ready-to-use APIs, provide captioning, object detection, tagging, and more without any configuration or training. In addition, we provide form recognizer for process automation scenarios like automated data extraction for documents. We also offer customizable version of vision models that can be tailored to a customer's specific scenario like brand recognition and logo detection. Developers can do this using computer vision OCR that extracts the text, words, metadata out of images and provides a structured JSON output and an SDK to query it. Let's take a look at the OCR engine at work. Here are some examples. OCR can detect and handle handwritten PDF, printed text, mixed languages, documents, and different languages. And it can detect, understand rotated and partially obscure text. All of this is possible without additional configuration or complexity to the developer. Video Indexer, part of the Vision services, extract rich insights from video and audio files. It's been used very heavily in the media industry. In today's time, running a physical store can be challenging due to new safety precautions, such as social distancing. We now have a new computer vision feature called spatial analysis to understand if people are keeping social distance in a retail store. Spatial analysis runs on AI on live and recorded video streams to understand people's movements within physical space. Spatial analysis allows you to monitor entryways for traffic and maintain optimal occupancy, detect when people enter and leave the zone or cross a line, calculate the time people spend in an area for dwell time and loitering. We delivered the spatial analysis capability in July this year with responsible use of AI and data privacy as it's one of the core top priorities for Microsoft. We released spatial analysis together with responsible AI recommendations grounded in user and societal research. We also use responsible AI innovation techniques to develop and test these features to to ensure the technology maximizes personal privacy, provides transparency, and promotes trust. Our principled approach enables developers to build rich solutions while upholding human dignity and needs of everyone impacted by the technology. Next, we have the speech services. These services transform speech inputs and outputs for scenarios like transcription, translation, verification, accessibility, chatbots, and more. Generating speech from text personifies the machine and makes it more human. Hence, the more realistic and natural sounding it is, the more convincing it can be. Text to speech is available in standard, neural, and custom versions. Let me play a video.
Show me all flights from Pittsburgh to Boston, both direct and connecting, that depart Pittsburgh after 7 p.m.
As you can see from the video, custom speech recognition can accurately understand accents and vernacular, as well as speak in a lifelike voice for natural user interaction. Language services help people in an organization to extract insights from text. Whether it's people of all abilities being able to read using immersive reader, reaching new markets through translation, building customer interactions, chatbots with language understanding, analyzing sentiment from social media feeds and text analytics. With the speech and language services, we recently provided European Parliament a service that automatically transcribes and translates parliamentary multilingual debates in real time in 24 official languages used by the parliament. This provides accessibility for people to understand real-time debates for those who don't have access to them in real time, in their language of choice, and for those hard of hearing. Let me play a video.
Liebe Kollegen, liebe Kolleginnen, ich möchte meinen ganz herzlichen Dank an die Berichterstatterin Katrin Styler aussprechen, die in diesem hochtechnischen Bereich eine sehr wichtige Arbeit gemacht hat. Denn es ist nicht nur ein technischer Bericht, es ist auch ein hochpolitischer Bericht, den wir vor uns liegen haben.
What I showed you was, as I played the video, you could hear a speaker could go between multiple languages very easily. With the world-class AI research, we are able to accelerate our growth momentum tremendously. With this overview, I want to share that we are seeing huge momentum of 22 billion transactions a month, powering external customers and Microsoft. You can see the growth momentum numbers on the left. We are going further to meet some of our customers' biggest challenges today by bringing Bing's large-scale Turing NLG models to customers, and our partnership with OpenAI brings leading-edge, large-scale AI models such as GPT-3 to Azure. Next, let me dive deeper and talk about the three key ingredients and share our learnings from Azure Cognitive Services operating at scale. Number one, unprecedented demand and world-class AI needs great compute. With everything online, we saw an unprecedented growth in April for Microsoft Teams with 75 million daily active users, generating 4.1 billion meeting minutes. Our modern platform got the most significant test with Teams traffic during COVID-19, an increase of 7x traffic within few weeks' time. Due to how we decompose the monolithic services into microservices with independent scaling across VMs and even scaling clusters, we were able to handle the traffic increases without any significant issues. I'll share more about the modern platform very shortly. Today, we are seeing about 115 million daily active users for Teams, and Azure Cognitive Services powers all the underlying scenarios such as transcription, captioning, and translation for Teams. In addition to the modern platform, our ability to scale for unprecedented demand was due to our reliance on Azure for mission-critical workloads. We are building Azure to be the world's computer, removing barriers for anyone who wants to migrate to cloud, addressing the data, sovereign, and regulatory needs. Number two, great AI needs great tools. Let me first talk about NLP, or natural language processing, and transformers. They have been advancing quite rapidly, and trend is towards a larger and larger models. The latest model from OpenAI, GPT-3, is literally off the chart here at 175 billion parameters. Even the smaller mainstream transformer models are an order of magnitude larger than the other models. For example, the popular ResNet 50 model used for image classification has about 25 million parameters. The transformer model BERT base has 110 million parameters. And as you can see from this chart, that's one of the smallest transformer models today. Transformers give great results for all the different NLP scenarios, but the large sizes of the transformers are one of the challenges of working with them. Training a transformer model from scratch requires a large amount of data and takes a lot of time. And once you have managed to train the model, deploying it to production has its own challenges. When tackling through these challenges, it's important to have the right tools. In terms of ML software and frameworks, here is what works well at Microsoft: PyTorch and Onyx Runtime. Most of you are familiar with PyTorch, and it's easy to learn. It keeps you productive thanks to its Pythonic design and dynamic eager mode. That's a part of the reason ML leaders like OpenAI have adopted PyTorch. Facebook and Microsoft also use PyTorch for their NLP research and development. So PyTorch is where the action is today. Onyx Runtime is an open source engine that helps accelerate inferencing and, more recently, training. The inferencing works on all major platforms, so it allows you to deploy same machine learning models to different devices. It's designed to handle even the most demanding workloads, and it's widely used at Microsoft. Let me share you a couple of examples from Azure Cognitive Services. The text analytics for health that we recently shipped as a cognitive services in July leveraged Onyx Runtime to reduce latency of their PyTorch-based entity recognition transformer model. For OCR, we saw 3.5x perf gain using Onyx and Onyx Runtime for image classification and text recognition for OCR. So why is Onyx Runtime faster? Like in training, it applies a wide variety of graph optimizations. It also performs certain transformer-specific fusions. It has very efficient implementations of the kernels for both CPU and GPU, and focuses on reducing memory copies between the devices. It also maximizes the use of available hardware so that when you use Onyx Runtime, you get the best possible perf on the hardware underneath. Onyx Runtime also has optimization for quantization, which results in smaller, faster transformer models. These are some of the reasons Onyx Runtime is widely adopted across the industry. It's production-grade engine that serves billions of requests in all the Microsoft products listed here. Users are also finding and appreciating not just the performance gains, but also the cross-platform flexibility. Number 3, enterprises demands great platform for running great AI. By 2018, we had a collection of 30 cognitive services, each under different organizations, as the color code in this slide indicates. These services were created using 5 variants of platforms, very, very expensive to maintain and support for enterprise as, not to mention the underlying cost of operations as well as the DevOps support, which is very, very critical for enterprises. To accelerate the modern platform, first we transformed these siloed services into 4 core pillars, as I discussed on vision, speech, language, and decision, for increased agility and depth on AI. We allocated most of our resources for model development. Next, we created the horizontal modern platform for consistency and scalability with 20% of team's resources. We have been practicing what is summarized in the book Loonshots with less than 10% of the resource to drive innovations, nurture innovation, and rapidly transition all innovations into Azure production services. We love both soldiers and artists and effectively manage and push the weak link between the two-phase transition. We introduced two common themes for these four pillars. We fully embrace pre-trained deep learning models. These generic models are robust, state-of-the-art, and can be used for a wide range of scenarios. These models can further be customized for different domains and tasks. Customization is part of our differentiation when we started Azure Cognitive Services. As I mentioned, before coming together, we had 5 variants of our platform, resulting in fragmented system and inefficiency. We wanted to unify all these services behind a single modern service platform for improved COGS, scale, and efficiency. The modern platform runs on top of Kubernetes, which is an open source tool for orchestrating containers on a cluster of nodes. At a high level, a service specifies Kubernetes a desired end state in a declarative manner that includes metadata such as what containers it is composed of, how the service communicates with other services in the cluster, how it accesses externalized state, such as storage and how many CPU cores and memory it needs. Kubernetes then performs a set of actions that ensure this desired end state. For example, if a service requests 3 replicas of a container to handle traffic, Kubernetes ensures that it spins up these containers at any point in time. The picture shows the configuration of the Kubernetes cluster in the hosting platform for a single region. Each cluster consists of one or more VM agent pools. All the VMs in each pool have the same SKU, such as CPU, GPU, local storage, and OS version. An individual cognitive services can declare its hardware and software requirements, and its container will be provisioned in the appropriate pool. For example, a service needing a certain SKU of GPUs will only be allocated to the pool that is GPU capable. In addition, we can also run dedicated clusters for larger workloads such as speech. Additionally, our customers are increasingly using multiple services together. For example, call center uses a combination of speech recognition, text-to-speech, language, translation, and so on. Our universal orchestrator in the modern platform enables this with a single request. I'm going to share some of the key learnings by aligning to the modern platform. First, we accelerated the regional availability and certification compliance. This shows a period of improvement within a year from 2018 to 2019, and today we have scaled much more beyond this. We have also enabled global availability across all Azure region with 24/7 live site and DevOps support, as well as alerting and incident management and automatic monitoring of key metrics such as SLA attainment, latencies, and so on. Next is uniformity. Uniform and out-of-the-box support for business continuity and disaster recovery. And Azure Enterprise requirements such as support for availability zones, security, privacy, compliance, responsibility, and other things such as code signing, certification management, and so on and so forth. And finally, not only we just reduce the overall cost, we also reduce the time for services to be onboarded. Time to deploy globally, time to scale the containers, time to scale the nodes, time to hotfix, and 0 manual touches. Let me summarize our efforts here. We are built on top of Azure that provides infrastructure capacity, enterprise scale, compliance, and security. We run the training and inferencing on top of our modern platform, Azure Machine Learning, and I only cover the inferencing in this talk. We also serve scenario-specific AI services with customization. And finally, developers can access these services through client libraries with a simple REST API call, or through a portal experience, or operate this in their own Kubernetes environment. Finally, we serve them to citizen developers and everyday users through our integration with other Microsoft offerings. Building a modern platform not only enabled us with agility and cost savings, it also helped us to focus our energy on building world-class responsible AI models and empower every person, every organization to achieve more. With that, I want to thank you all.
Now comes the exciting part of the talk. We will be starting the first demo. I would like to invite my colleague Chris Hodder to go inside Vision Services and present a demo. Take it over, Chris.
Azure's cognitive services provide developers with a wide range of out-of-the-box intelligent capabilities, from analyzing images to drawing real-time insights from live video streams. These capabilities are available to developers as REST APIs, through our client libraries, and through integrations with other products such as the Power Platform. Cognitive services can be deployed anywhere, from in the cloud to on-premise or any cloud using containers. Today, we'll walk through a few examples of these capabilities within the Vision Cognitive Services. To get started, imagine we're running a large retail store called Contoso, who has ambitions and goals to both improve the customer experience and optimize internal efficiency. In today's times, running a physical store can be challenging due to new safety precautions such as social distancing. At Contoso, they're leveraging a new feature of computer vision called spatial analysis to understand if people are keeping a good social distance. Spatial analysis runs AI on live and recorded video streams to understand people's movements within a physical space. Contoso developers use one of the service's many features to analyze camera feeds and set a minimum required distance between people. The service will then emit events that can be sent to frontline employees or used for historic compliance analysis. Spatial analysis runs on a Docker container that can be deployed on-prem or at the edge. To get set up, Contoso developers start by deploying the spatial analysis container on an Azure IoT Edge device connected to an Azure IoT Hub service that you can see here. Here we have the deployment manifest, which tells the device what to install and sets the configuration. Among the many configurations, you can see that we define the spatial analysis container, the person distance operation, the URL to the video stream that we are analyzing, and finally the minimum distance threshold of 6 feet. So we've now deployed the container, and you can see it running here on an IoT Edge device. Every time people are within the minimum distance, we'll receive an event like this. Each event is a JSON object that contains the event type, the total number of people detected in the zone, an alert that the alert is because people are too close, and finally that it's 2 of the 5 people who are too close. Spatial analysis can be used for more than just understanding social distancing. It can be used to count people in a designated area, monitor and alert for maximum occupancy, and calculate dwell time. As with all of our services, privacy and the responsible use of AI is a top concern and priority for us at Microsoft. In this case, spatial analysis allows Contoso to create a solution that ensures their customers' privacy. The solution is implemented at the edge so no video footage leaves the building, and the emitted events are also de-identified, so the only information that leaves the system is how many people are in the space and how many are within 6 feet of each other. Now let's look at Contoso's goals around improving their employee experience, starting with improving accessibility. Microsoft's Vision products provide numerous features and capabilities for extracting insights and information from images to empower users of all kinds. We start by offering a core set of base features and capabilities in our computer vision service. These are out-of-the-box, ready-to-use APIs that provide captioning, object detection, tagging, and more without any configuration or training. Let's look at these capabilities in action, starting with how Contoso can use our state-of-the-art image captioning capabilities in computer vision to drive accessibility. Here we can see Microsoft's Seeing AI app and how it uses image captioning to describe photos with natural language. It's a perfect example of an AI breakthrough that was immediately available in our products and enables a broad range of use cases just like the one shown here. So how would a developer typically generate these captions? Here you can see some sample code using our client library to access the underlying REST API. Developers can do this by uploading an image directly or providing a URL. For the purposes of this demo, we're looking to generate the caption using our describe image endpoint. The service returns a JSON object containing all of the metadata that was detected in the image, including the full sentence caption. Let's move on to our next scenario. Contoso also has unique needs and requirements where customizable services like Custom Vision can help. With Custom Vision, developers can build bespoke models unique to their use case without having to understand the complexity of training scripts and model architectures. They can get started with one of several specialized domains such as logos and products that are already pre-trained, so they're not starting from scratch. Developers can do data labeling, model training, evaluation, and inferencing through our UI shown here, or using simple APIs. All of these capabilities are available at your fingertips without needing to learn how to build machine learning models from scratch. But don't let the simplicity fool you. The service still supports many advanced training and optimization features to help users create the right model for their use case. For example, the service supports a variety of model architectures with different memory and latency characteristics, from low latency mobile inference to high quality hosted cloud prediction. Let's look at an area where Contoso wants to improve their employee efficiency by using custom vision. Employees often spend a significant amount of time understanding their current inventory and restocking shelves. To streamline the process, the team wants to identify what products are available on the shelves using images captured in the aisles. Since Contoso has many specific products that they want to identify, they'll need a customized model in order to reach the desired accuracy and performance. Let's look at the developer experience by jumping into the Custom Vision portal. I've already taken the steps to create my resource, start a new object detection project, and upload some example images from our store aisles. If we select one of them, you can see that the image is already partially labeled. We've got Dr. Pepper, A&W, and more. But the image isn't fully labeled, and we have to go in and complete that process. To do this, developers can leverage Azure's Smart Labeler to generate suggested tags for the images, allowing them to label a larger number of images more quickly when training custom vision models. All we have to do is hover over, and we'll see a region suggestion appear. Developers simply need to click, add the tag, and a label. Let's go ahead and do this for Squirt, RC Cola, and Canada Dry. You can see when we don't have to adjust the boundary box, it's much easier to use the Smart Labeler. Now, once we have enough labels added, developers can go and train the custom vision model by clicking Train. Here, developers can use either a quick train for quick iterations during initial setup, or select advanced training to ensure that we get the highest performance. Once the training is complete, we can understand the quality by inspecting measures such as precision, recall, and MAP of the model on the dataset. Finally, once the model is ready to use, we can publish and receive an endpoint that's ready to receive predictions. As a developer, we can now take this REST endpoint and integrate it into our mobile application or anywhere else. Like any large company, Contoso spends a considerable amount of time training employees, and a large portion of their training content is delivered through videos. They would like to make their archive of training videos more accessible and discoverable for new hires, and they can use our video indexer to do exactly that. At its core, Video Indexer is a pipeline that orchestrates multiple machine learning models together in order to extract as much as possible from a video. While the pipeline may appear extremely complex, the output is extremely simple. It's a single JSON file. Let's look at how a developer can set this up and bring value to Contoso and their employees. After deploying the service in Azure, a developer can upload videos using one API or through the product's UI, which we'll show in a moment. Once the video is uploaded, the entire set of insights will run. No data science expertise or media knowledge is needed. No effort is needed to integrate models together. It's as simple as one call. Once the video is indexed, you get that one JSON file containing all of your insights. You can take this file and use it for your own business needs, or you can use Video Indexer's UI to search your video and easily discover content. Everything in the portal is backed by APIs available to developers, and the player, insights pane, and editor in the portal are widgetizable, so they can easily be integrated into a developer's own website. For example, I can click here to get the code to embed the media player in my own company's website. To see the value Video Indexer provides, let's look at a video I've already uploaded and indexed. This is a training video where Microsoft CEO Satya Nadella talks about accessibility. First, let's look at the timeline, which shows the full transcript that was extracted by the service. This transcript can be translated into 54 different languages, and we can use this translation to create closed captions directly in the player. The transcription, translation, and closed caption features provide a more accessible and inclusive experience to all employees. Video Indexer allows for even more insights by enabling employees to perform deep searches on the archives to find relevant topics or speakers and jump to the specific parts in the training videos they want to see. For example, here I can jump to the exact moment where Brad Smith is speaking. We can do this because people detection is one of the many additional insights available. All the people that appear in the video are detected and recognized, either out of the box using celebrity recognition or through custom face models that developers can incorporate. Here we used our own custom model to identify Microsoft's executive leadership in the video. These are only some of the insights that Video Indexer extracts and makes available. It's also able to identify objects, scenes, keyframes, named entities like brands and locations, content moderation, and much more. And remember, all of this is available within that single JSON file. Let's now look at our final scenario. Just as with any retail business, Contoso receives, processes, and analyzes hundreds of invoices every day. Considerable effort is spent digitizing and processing physical forms like the examples shown here. The result is a huge number of PDFs and images of invoices sitting on the company data store, and they want to act on these invoices with minimal effort. Let's look at how we can solve Contoso's problem using these 3 invoice examples, each with the different formats and styles. First thing we need to do is extract the text from the images in PDFs. Developers can do this using the Computer Vision's Read API that extracts the text, words, and metadata out of images and provides a structured JSON output and an SDK to query it. Performing this operation is as simple as calling a REST API endpoint. Developers can send information across a variety of formats, sizes, and number of pages. Let me run that quickly here, using our Python library to show you an example of the code needed in an output. Let's take a look at some examples of the OCR engine at work. OCR can detect and handle handwritten and printed text, mixed language documents, including 9 different languages and growing. And it can detect and understand rotated and partially obscured text. All of this is possible without any additional configuration or complexity to the developer. It's the same API. But what developers want is not just the text and where it is, but to pull it out in an actual key value pair from the data. This is where Azure's Form Recognizer comes into play, building value on top of our leading OCR engine. Let's look at how Contoso developers can use Form Recognizer to process their invoices. Here we have the Forms OCR testing tool. It's an open source testing tool that all developers can download from GitHub. This application lets you connect directly to storage. Here we have a blob store populated with examples of these 3 invoice types. We can then create a project of each of our suppliers to create a custom form model for each. To train the custom forms model, developers first run OCR to extract the text from the image, and then they have to go through and label it. This will specify the specific keys and values the model will extract. Once we've done that, we can train our model and repeat for the other invoices. Jumping ahead, we now have separate models for all 3 invoices, but there's still a challenge. We only want one model, and we don't always know which invoice version will be provided to us. This is actually easy to do in Form Recognizer using the Compose Model feature, which will automatically detect which model to use. All right, now that all the training is complete, let's test it out. Let's choose an invoice that hasn't been seen before and run it through the model and download the output. You'll see we get read results, page results, and document results as the 3 main groups returned. We also know which model was used, as well as important information such as when the invoice was due, for how much, and where we are sending it. Form Recognizer also provides pre-built models which build on our OCR capabilities but don't require customers to provide training data. Today we offer this for receipts, and we'll soon be releasing pre-built capabilities for invoices as well. For business experts or citizen developers, we offer a full low-code experience with our native integrations with AI Builder and the Power Platform. For OCR, Form Recognizer, and many of our other cognitive services, we offer containerized versions of the endpoints that developers can deploy and configure in their own environment. This ensures that their data stays private. At Microsoft, we aim to meet the developer on their terms and empower them to leverage our AI capabilities in their own unique ways. Thank you.
Thank you, Chris, and hope you all enjoyed the demo on Vision Services. Let me invite Gary, along with Chris again, to present the next demo on enabling speech for bot services. Hope you enjoyed this demo, and then let us know if you have any questions. Take it away, Gary and Chris.
Hi, my name is Gary, and along with my colleague Chris, we're going to show you how a developer would typically access Microsoft's conversational AI language services and use them to enhance applications. Our scenario centers around a company in the healthcare industry that is using AI across their business. Let's first look at how our healthcare company is developing a virtual assistant to help their employees. Microsoft provides options for people of all skill levels to create conversational AI solutions. We are the only cloud provider with no-code tools for business users to build bots, as well as a rich SDK and tooling for developers. Developers can use the open source Bot Framework platform, starting with the low-code IDE Bot Framework Composer. This allows for rapid development of sophisticated conversational applications and can be extended where needed with the powerful Bot Framework SDK, which supports .NET, Node.js, Python, and Java. Business users can use the Power Virtual Agents for a code-free experience within the Power Platform ecosystem. Since Power Virtual Agents is built on top of Bot Framework, the services work together to allow business users and developers to collaborate to build the virtual assistant solution. The development team within our healthcare business have been asked to develop a bot which can form part of the virtual assistant that allows users to view and manage their calendar within Office 365, including the ability to create meetings, get details about attendees, and check what's upcoming on their schedule. They can use Bot Framework Composer to rapidly build out this capability. They can take advantage of the adaptive dialogue system to design a conversation flow based on context and events. Adding triggers for events, such as when a natural language intent is recognized, they can add one or more actions to their canvas that should be executed in response. Composer has built-in actions for receiving input from users, adding conditional logic to the flow, managing bot state, and accessing external resources such as web services. Developers can also build custom actions to use within their bot, such as those seen here for integrating with the Microsoft Graph. Using tools such as Visual Studio with the Bot Framework SDK, example projects and templates are provided, allowing developers to extend their projects with minimal effort. Combining multiple triggers allows for the handling of complex conversation, such as interruption and context switching. Composer also integrates the language understanding and Q&A maker cognitive services into the developer workflow, allowing the developer to manage their language models from within the context of Composer, reducing the need for context switching between multiple portals. During development, developers can test their bot locally using the Bot Framework emulator. Here you can see that if a user asks the bot about the meetings on their calendar for today, the Lewis language model that was published for us by Composer is queried, the matching intent is returned, and the find event trigger that was defined in Composer is fired, showing the user their upcoming meetings. The user could then follow up with a contextual query about the meeting attendees, which is handled by a different trigger and set of actions. Using this approach is what allows for effective context switching and interruption handling that make the conversations built with Composer feel so natural. All of these scenarios were rapidly built using the available actions within Composer and then extended using the custom actions for integration with the Office Graph to enable more complex capabilities, such as the one shown here where the bot identifies potential meeting times where all of the attendees are available. Once ready, developers can provision resources and publish to Azure directly from within Composer, or by deploying as part of a CI/CD pipeline. The bot can then be made available via Azure Bot Service on channels such as Microsoft Teams, web, or mobile. However, in the case of our healthcare company, a different team, mostly comprised of business users, are building the core of the virtual assistant in Power Virtual Agents, and have already added capabilities for employees to manage support tickets and requisitions. The team could now surface the capabilities of the calendar bot we saw built with Composer by consuming it as a skill, demonstrating the ability for business users and developers to work together on such solutions, choosing the right tool for the task or audience. Deeper collaboration is also now possible thanks to continued integration between Bot Framework Composer and PVA, with PVA bots now able to be opened directly within Composer, to be extended by developers and then published back to the SaaS platform. In this case, a developer has added triggers and dialogues using Composer to allow employees to manage vacation time, and once published back to PVA, we can see these listed alongside the existing topics. The bot, with the additional topics added using Composer, can then be tested immediately using the PVA testing tools. So far, we've created a text-based virtual assistant, but what if we wanted to extend this bot to allow voice interaction? Next, my colleague Chris will show you how to leverage Azure Cognitive Services text-to-speech capabilities.
Thanks, Gary. To add speech capabilities to our bot, we'll use text-to-speech to convert text into lifelike speech. We currently provide developers with the choice of over 140 voices covering 49 languages and variances, as well as many different speaking styles. This provides the most comprehensive language support on the market and lets you create a unique brand voice for your application. Developers can generate the audio via a set of REST APIs, SDKs in 8 languages, or through a rich UI-based experience in our speech portal. Customers can then deploy the text-to-speech capabilities in the cloud, on the edge, or on-prem. Let's take a look at how the developers at our healthcare company can get started integrating text-to-speech to their solution with a simple code example using our C# speech client library. Here we have a sample code that will configure the client, synthesize the text we write to the console, and play it back for us to hear. Let's run this with an example input.
Good morning. Thank you for calling ABC Hospital.
As you can hear, our neural text-to-speech enables incredibly natural and fluid speech that matches the patterns and intonation of human voices. Next, I'll demonstrate how to easily fine-tune the voice output without writing any code using our audio content creation tool within the Speech Studio. This tool lets you easily configure and optimize your solution to fit your scenario even better. Here you can choose from a wide range of options such as choosing what voice to synthesize, changing the speaking style, adjusting the voice pitch and intonation, and controlling the pronunciation. Finally, once you finish tuning your model, you can turn to the SSML view and copy the final SSML with all of your configurations back into your code. Microsoft also provides other ways for customers to customize their solutions to their brands. For example, Microsoft's Custom Neural Voice enables customers to customize the voice font to their own voice. To set this up, users need to record studio quality audio and upload the recordings as training data. Then it's as simple as clicking the train button. Microsoft does the rest, creating a unique voice font for your bot, tuned with your data, and ready to use a unique API endpoint. Microsoft is also committed to ensuring that companies use these types of technologies responsibly and has published guidelines on their responsible deployment and use. And our custom neural voice capability is offered with limited access to ensure customers are equipped to build these solutions following our responsible AI principles. Let's move on to our next demo. In addition to helping their employees, our healthcare company is also using Azure AI to enhance their customer service. They have a contact center with agents providing patients assistance 24/7. With Azure AI, these agents are assisted in real time with relevant information to help better serve their patients' needs. Let's look at the Agent Assist experience, including some of our latest innovations in the area of real-time call analytics.
I get a prescription for blood pressure from my doctor, but I don't know if I take the right amount.
Okay, what is specified on your prescription?
2 pills of 10x per day.
And do you feel any stomach pain or headache?
No, but I feel dizzy.
Okay, slight dizziness is a normal side effect.
I was really worried. That's great to hear. Thank you.
You're welcome. And is there anything else I can help you with?
No, that was it. Goodbye.
As you just saw, this AI-powered Agent Assist solution helped the agent improve his productivity and provided a great customer experience to the patient. We accurately transcribe the conversation in real time, give the agent indications of the customer's intent, and are able to recognize and extract the customer's medication name. Now, let's take a look at how any developer could build this solution. We'll start with speech and our speech-to-text capabilities. We offer pre-built speech models which are highly accurate out of the box. In fact, Microsoft was the first to achieve human parity for speech recognition back in 2017. These pre-built models can be accessed, like all of our services, via a REST API or client libraries in the most popular programming languages. Speech Studio also provides an easy way for developers to build, train, and configure custom speech models. Users can customize a model with their own training data and include domain-specific terminology. To show how a developer would build this Agent Assist solution, I've already taken the steps of deploying a speech resource and setting up a custom speech project. Starting on the Data tab, developers can upload data to train and evaluate their custom speech model. This data is used to tune the provided baseline models with your domain-specific training data. This data can be in many formats, such as audio in this example.
Can I take 10x right before bed?
Notice that the term 10x is a custom medication name, or the data can be just text, as we're showing here. Notice again the use of the term 10x. Once we've uploaded all the data, we can create a unique custom model by fine-tuning one of the base models offered by Microsoft. From here, we can also keep track of which data was used to train the model. Now that we've trained our custom speech model, we'll want to evaluate the performance of our new model against the out-of-the-box offering or our prior custom model. Here we've already run an evaluation of our new model against the baseline. Notice the significant improvement in the performance between our custom model and the baseline model. We can even click to learn more and see that the baseline model has trouble recognizing this custom medical term 10x, but our custom model now recognizes this accurately. So now you've seen how easy it is to create custom models that extend our state-of-the-art pre-built models to your own unique vocab. Let's now look at the next step in the application flow. We want to analyze the recognized text to understand more about what the patient is asking. To do this, we'll add natural language processing capabilities into our solution. Microsoft's Language Understanding Service is a great solution here because it offers a flexible way to add intelligence to conversations, extract relevant information, and predict overall meaning. Let's look at how a developer can do this to understand custom medical terms for our Agent Assist use case. First, intents in Lewis represent the intention of our users interacting with our application. For example, conversations related to a prescription or more generic questions about a medication. Entities in Lewis are metadata that we want to extract in a structured way so that we can query on them and present useful information to the application user. Let's go back to intents and look at the medication Q&A intent. Here we have a list of utterances that make up the intent. These utterances are labeled with the entities we looked at previously, medications and intake details. I can add an example utterance and see that 10x is detected as a medication and that this part of the sentence is suggested as an intake detail. This is correct and I can click to confirm. We have now added a new label data example that can be incorporated into our AI model. Next, we can click Train and Publish to Production to create a live endpoint with this model that we can call. Now let's bring together the custom speech model and our custom language understanding model. This could be an Agent Assist application like the one we showed earlier, But for this demo, I'm going to show a simple code example. Here I'm going to set up the code to call our custom speech model, get back the results, output them, and then call the language understanding service and print out the return JSON object. Let me run this script now. I'm wondering if I can take 10x right before going to sleep. Here we can see that the text is recognized perfectly, and the output from the language understanding model recognizes that the medication is 10x, and that the intake detail is asking about taking it right before we go to sleep. So now we've shown you an example about how to use custom speech and custom language understanding models to create something like we showed in the Agent Assist demo. Let's now look at a few of our other natural language processing capabilities available as part of the cognitive services. We start by offering a core set of base features and capabilities with services like text analytics and translator. These are out-of-the-box, ready-to-use APIs that provide general capabilities like sentiment analysis, opinion mining, and translation. We also offer many ways to customize these models for users who need improved accuracy on their own unique use case and data. For example, services like Translator allow customers to create custom models based on their domain-specific data. All of these models are backed by our cutting-edge research that is continuing to push the boundaries of what's possible, and they're then bringing these capabilities to customers via these simple APIs. For example, Microsoft Research was the first to achieve human parity in the General Language Understanding Evaluation benchmark in 2019. In our healthcare example, the company wants to leverage natural language processing to extract insights from their numerous unstructured medical documents, such as clinical notes and electronic health records. These documents also cover many different languages that will need to be translated. Let's start by looking at translating documents using the Cognitive Services Translator service. We currently support over 70 languages in both batch and real-time translation, but at its core, the service is a simple stateless REST API using JSON request and response formats. Here we have an example in Postman showing a translate request. Our API key is hidden in the header, and the text you'll want to translate is in the body of the request. Users can also specify the source and target languages in the URL. If a source language isn't specified, the service will auto-detect it for you, and you can also specify multiple source or target languages. Here we're translating English to French, Greek, and Japanese. Sometimes, though, it is necessary or helpful to adjust the translation to industry-specific terminology and style. Custom Translator can build that for you, and you can start with the corpus of your previously translated data. 10,000 translated sentences are a good start, but there's no upper limit to it. The more you provide will help the system make better decisions based on the context provided in these documents. Each project in Custom Translator represents a language pair and a domain. In the Custom Translator portal, you can see test scores and results for all of your different projects. To use your Custom Translator model, you'll just need to add a reference to your model or category ID as one of the parameters to the same translation request we showed earlier. Translator also powers the translation functions in all Microsoft products, from Office, Edge, Teams, Yammer, PowerPoint, Bing, to the Translator consumer apps. Of course, automatic translation also helps Microsoft interpret customer feedback, bug reports, social media, and to publish its knowledge bases and articles. Microsoft has also put emphasis on making speech translation great, which is a key feature when creating solutions like our Agent Assist example. The Speech API can transcribe and translate at once, allowing close to real-time conversations across the language barrier. You can see this implemented in PowerPoint, and you can speak one language and you'll see the captions in another. Now that we've translated our documents, we'll need to leverage text analytics to extract valuable insights from them. Text analytics enables you to extract key phrases, detect over 90 languages from text, extract over 100 types of named entities, and perform sentiment analysis at the document and sentence level. Like all services, these capabilities can be accessed via REST APIs or SDKs. And you can use our cloud-hosted endpoints or deploy capabilities on-prem or at the edge with containers. A key part of running any business is understanding your customer's opinion and sentiment about the products and services that you offer. This is also true in healthcare, where you might want to analyze the sentiment of reviews of recent customer visits. With a simple API call, you can analyze text for positive, negative, neutral, and mixed sentiment at both the document and sentence level. We also offer opinion mining, which gives you even more granularity by providing something known as aspect-based sentiment analysis. This will provide you with information on the opinion of different aspects within a sentence. Let's look at how a developer can leverage both of these capabilities with our Python SDK. Here we'll pass an example review of a customer saying they had a great experience in their recent visit, but that the food was just okay. You can see we extract a positive sentiment for the first two sentences, but neutral for the third. We can now rerun the same API call, but this time including a flag to include our opinion mining feature. Now we get even more granular information and know that the user's opinion on the experience was that it was the best, while the opinion on the food was that it was okay. Finally, our healthcare customer can leverage text analytics for health, which enables developers to process and extract insights from unstructured medical documents. Trained on a diverse range of medical data, text analytics for health can detect domain-specific entities like diagnosis and medication names. This API can also extract over 100 types of personally identifiable information with no training needed. Let's see it in action. Here I have text analytics for health running in a container, and I'm going to analyze some text from a doctor's note. You can see here that we're able to extract entities and relationships specific to the medical domain without having to do any of our own custom training or modeling. In summary, Microsoft is the only cloud provider with cloud AI developer services that empower both professional and citizen developers, from code-first solutions with the Azure Cognitive Services to code-free solutions with Power Platform, including the Power of Virtual Agents and AI Builder. We also have an uncompromising commitment to responsible AI. We apply responsible AI guidelines and standards throughout the software development lifecycle and never use customer data to train our models. We also offer tools and resources to help others understand, protect, and control their AI at every stage of innovation. And we continue to innovate to simplify the developer experience. For example, to address the significant customer demand we are seeing in Agent Assist and post-call analytics scenarios, in 2021, we plan to launch a new product which will provide an out-of-the-box solution for these use cases. This will also have a streamlined developer experience, giving customers the fastest time to value for building intelligent contact center solutions. This is just one of the scenario-specific services we plan to launch in 2021, all aimed at accelerating the development of specific solutions even further. Azure AI enables developers to responsibly build mission-critical AI-powered language solutions, from chatbots to agent assist solutions to applications with translation and natural language processing capabilities, and much, much more. Thank you.
Thank you, Gary and Chris. I hope you enjoyed the entire talk and the demos. Before we get to Q&A, I want to talk about the rest of the event. We have 8 more exciting talks at this event. We will talk about Inside OCR Form Recognizer by Sanjeev, Computer Vision by Varsha, Azure Speech Services by Oliver Scholes, along with Vish as well as Panos, Text Analytics by Parashar Shah, Inside Q&A Maker by Neha. Then we have some exciting talks on challenges in building machine learning models for Indian languages by Krishna, followed by reinforcement learning from Amit, and running sophisticated virtual assistants using our Azure Bot Service conversational AI platform from Gary. Hope you enjoy the rest of the event by tuning into all these talks. Now let's go to our Q&A.